0.1, y 0.2 using the differential equation y prime equals to 1 plus xy with initial condition okay. If you want to know, let's just give you some background information. Like, how do you solve this differential equation? 1 plus xy. We can solve this. One way to solve this is y prime equals to minus xy equals to 1. Using the integration factor method, I don't know if you remember integration factor method, dy dx plus px y is equals to qx. Using the integration factor method, you can solve this. So you should have learned this from your previous mathematics class. Using the integration factor method, if is e to the px dx. So in this problem, the integration factor is going to be minus x dx. It's going to be e to the minus x. That's the integration factor. In the previous mathematics class, like mathematics 1a, 2a, like maybe 1b, you might have learned this somewhere. Then we use the integration factor to multiply through the differential equation y prime e to the minus x minus xy e to the minus x is equals to e to the minus x. This is equivalent to e to the minus x prime, c to the minus x. Next, if I integrate on both sides, if you integrate on both sides, you'll get, you integrate you will get y e to the minus x is equals to e to the minus x divided by 1 minus 1 plus c is equals to minus 1 plus cex. Okay, using the initial conditions are given to you when x equal to 0. I can use the initial condition to find c. Y is equal to 1. Therefore, c is going to be 2. Therefore, the solution to this differential equation is, okay, if you plot this curve, okay, this is not numerical solution. This is, I'm just reviewing from your previous class. If I want to plot this, let's say just pick 3 points, minus 1, 1, minus 1, 0, 1. When x equal to minus 1, you're going to get minus 1 plus 2 over e. 2 over e is, well, how much is 2 over e? 2 over 2 divided by 2 divide. It's approximately around, I think, minus 0.3. when x equal to 0, it's going to be 1. It's around 3.7. Sorry, it's going to be around e to the power of 1, 2.7 times 2 minus 1. Approximately around around 4.4. So if you sketch this curve, so it's 0, at 0, it's 1. Am I right? At 0 is around 1. At minus 1 is around 0.3. This is 0. It's around minus 0.3, somewhere here. At 1, it's going to be around 4.0, so somewhere here. Okay, so just need a 3 points to roughly estimate the curve. So this is the solution to that differential equation. But now we are asking you to find a solution. This is x 0, 1. You are given this point. You are given, and then you are told to find what is the value of 1.1. What is 1.1? Like what is 1.2? So this we are going to solve by numerical Taylor series method. By the way, I'm doing this problem to help you in your previous assignment. The previous assignment is supposed to compare the exact solution with a numerical solution. So you guys are still following?
Yes, sir.
Yes, sir.
Okay, now calculate y 0.1 using Taylor series. Taylor series expansion. Taylor series expansion around Taylor series Taylor series expansion at x is given by x plus delta x. Like in this example here, you know, if this is okay, this is your x 0, 1. Let's say xy, and then you're going to find out what is and 0.1. Like we're going to find the y value some delta x away from x. So this point, this is like a 0.1. Maybe if x is 1, if x was 0, in this case, what is the initial point? Initial point x equal to 0. X equal to 0. So I'm sorry, this is 0. X is 0, then you want to find what is 0.1. Initial value 0, delta x y is x plus delta x. The initial value is 0, delta x is 0.1. So it's like y 0.1 equals to what? So delta x is 0.1. Then what's the y value? So you're going to find that using the Taylor series expansion. Taylor series expansion formula is yx plus delta x is equals to yx plus delta x y prime x over 1 factorial plus delta x squared y prime or y double prime x over 2 factorial. That's the general formula, but this is sufficient if you want to do just for second order Taylor series expansion when you have y prime and y double prime. And if you want a third order, which will give you more accuracy, is 1 over 3 factorial or just delta x cube y triple prime x divided by 3 factorial and so on. Okay. In Taylor series formula, in the h, the step size delta x is same as h, the step size, something like a step size. Okay, when you do the first iteration, y1, we want to find y1. We know what's y naught and x naught. To find y1, y1 is the point that you're trying to find at x plus delta x. Like this is your y1. Is y naught plus delta x. Sometimes delta x also can be called h. You can just leave it as delta x if you like. Delta x, 1 factorial is 1, and y naught prime plus delta x squared, y naught double prime divided by 2 factorial plus delta x cube 3 factorial. Okay, we're going to do up to third order in this case. So next you go ahead and find y prime was given as 1 plus xy. Y double prime, take the second derivative. Second derivative. By the way, this means a dy dx. Second derivative with respect to x is going to be 0, and then you apply the product rule on this. Xy prime plus y. Take the derivative again. You apply the product rule on this again. You take the derivative of this again. So it's going to be xy prime plus y prime. Take the derivative of this. You're going to get x y double prime, applying the product rule, plus y prime plus y prime. So that's going to give you x y double prime plus 2y prime. Given. So now you're going to evaluate all the first derivative, second derivative, third derivative using the initial condition with the delta x is equal to 0.1. Okay, given x naught is 0, y naught is 0, and delta x is 0.1. So let's evaluate y01. Y01 is 1 plus x naught y naught. Okay, so that's going to be 1 plus 0 multiplied by 1, which is 1. Y naught double prime is x naught y naught prime. Zero, 1, you just plug in 0, 1 at y naught y prime. Just plugging in values. Y naught triple prime is x naught prime plus 2 y naught prime, which is going to be x naught is 0, y triple prime. If you plug in the previous value, what's going on here? You must understand, like, where did I get y naught prime from here? Like in this one, see this y, this value comes from here. Okay. Maybe.
So,
Yeah.
y triple pi should be equal to x y double pi, am I right? It's not x not y triple pi.
Say that again.
Y not triple pi equal to x not why not double pi only, sir? Is it?
Yeah, supposed to be, why not? Yes. Thanks. Okay. So this value comes from here. This value comes from here. Then this value, why not triple prime, it comes from here. So you need prior values. You need to evaluate prior values before finding the subsequent values for the next derivative. So x naught here is 0. Doesn't matter what you get for y double prime is 1. Y double prime not is 1 plus 2. Y naught prime was evaluated earlier is 1. So it's 2. So that's how you evaluate. You evaluate all these things and then you plug that into the Taylor series expansion formula. So going back to that formula, the formula is right here. Since we are only doing up to third order, so just plug them in. You got everything. Y naught prime is 1. Delta x squared 0.1 squared. Y naught double prime is 1. Divide by 2 factorial. 2 times 1 plus 0.1 cube. Y naught triple prime is 2. Okay, then you, next, you know what? Next, plug and chug. So therefore, y1 is equals to y at x plus delta x is 0.1. So this is x plus delta x, 0.1. That's going to be, that is 1.105. When x1 is equals to 0.1. Any question?
No, sir.
No, sir.
Second
No, sir.
iteration. Okay. Second iteration. second iteration. To find second iteration, then you go ahead and find y2. y2, earlier on to find y1, same formula. Now you're going to change the subscript. In general, the formula is like this. Like, it's going to be, okay. And this is like, for example, yn, then it's going to be like delta x or 1 factorial y n minus 1, something like, okay, y n minus 1. And so on. Okay, this is a general formula, but you don't really have to remember this formula because we only doing a few iterations. Later on, when you want to program these things, then you may need this formula. So y2 is going to be delta x, so y1 plus delta x or 1 factorial plus delta x squared or 2 factorial y1 double prime plus delta x cube dy by 3 factorial y1 triple prime. So let's evaluate what's y1 prime. Y1 prime is same as the equation is same as before. You don't have to go in a differentiate again. You already done this before. So you just change the subscript. Is equals to 1 plus x1 y1. X1 and y1 we calculated earlier. X1, you know that interval 0.1. Y1 was calculated earlier, 1.105. So that's going to give you 1.1105. Y1 double prime, same formula with a different subscript. Y1 was found earlier plus delta x, and then y1 prime.
Sir,
Okay, this is the journey that was
Sir.
called how
Yes.
the strategic speed track
for y1 is 1.1105, not 1.1105, sir.
Y1,
Yeah, for y1 is 1.1105.
Y1 is 1.1105.
1105, sir. Not 1.105.
Okay, these are the agencies that
Y is 1.
involved in the catch and control
1.105.
of the licenses.
Uh,
Some of it,
ah,
the violation customs,
1.105, right?
right, sir.
Any other question? Y prime will come from here. Y1 prime. Y1 triple prime. X1 0.1. Y1 double prime 1.216 plus 2 times Y1 prime is 1.1105. So that's going to give you 2.3426. Okay, now you have all the values here that you need to find Y2. It's Y1 plus delta X 1 factorial Y1 prime plus delta X squared 2 factorial is Y1 double prime multiplied by H cube, sorry, not delta X cube over 3 factorial now you plug in all those values in. Y1 is 1.105, 0.1 delta X, Y1 prime is 1.1105 plus delta X squared over 2. Y1 double prime is 1.216 plus delta X cube. 3 factorial is 6. And then multiplied by Y1 triple prime, which is 2.3426. If we punch it in, you'll get 1.105 plus 0.1105 0.11105 plus 100,608 0.00039. That's going to give you Y2 is 1.22252. Therefore, Y 0.2 is equals to 1.22. Maybe there's a typo here. I think maybe 11252. Maybe you may want to check these answers. They may be, to make sure that there may be small error here in the decimal places or some numbers. Okay, the method is important. So that's all I have for today. If you guys have any question, then
No, sir.
there's an example here that you can practice. Okay, go ahead and practice this. In between steps are not shown. You show your own steps and make sure you know how to do. Okay, any other question?